Hi there everybody, welcome again to my channel. Today we're going to continue what we started last week, and we're going to talk again about the AGGR function, and we will advance a little bit and show more uses. This is definitely not the last episode about the AGGR. There are so many uses, and we'll probably need another one to cover it all. So let's just make a small summation, recap of what we talked about last week. We talked about the AGGR function. We explained that actually the AGGR function is a way for us in qlik to create a temporary table in which we can do everything we can do in a table, dimension and measures, and qlik sense return to us when the function is finished. When the function finishes calculating, return to us an array of values, which is the list of values represented by the measures in the table. AGGR function can only return one array, one measure, but it can be consist from several dimensions. So we create a temporary table with as many dimensions as we want and one expression, and qlik sense calculate this table and return to us the element list, the numbers or the values which are represented by the measures in each line of this table. And from then on we can do many things with this element list. We can use it inside another aggregation and circle it inside another aggregation and get the max of the values that is returned, the max measure from the results of the table that we got. For example, we had a table with customers and sales, and we wanted to know what month was the biggest months for each customer. So we wanted to return the month for each customer, which has the largest sales amount, and we wanted to put it in another table. So we used the AGGR function, and we passed it on to a max function. So this function was creating a temporary table of some sales by customers and month year, and for each table that was created here, we returned the max value. This returned to us a list of values representing the sum of sales for each customer in each month, and the max function took the largest of them all. And since we are using it inside a table with the customer in dimension, then for each line it consists of only one customer, so it gives us the max month value of sales for each customer. We also seen the way that we can influence the difference between calculating a total expression or sum of rows, and we saw how we can change the way qlik sense calculates the total line, with or without whether it calculates the sum of expression, the total of the first expression minus the total of the second expression, or it calculates the total sales minus cost of goods for each row, and then calculates the total by summing all those numbers. And we've seen how it can be different in certain cases. And we also have seen how in pivot table, in straight table, in a regular table, in qlik sense, we can use what is called the total function. The total function, and tell qlik sense either to do an auto calculation of totals, that is, calculate the total of the expression, take the same expression, but run it around all the other values and not only values for each dimension, like for in this example for each customer, but take all the values of sales and all the values of goods and subtract one from the other and get the results. While if we use one of the other functions like max or min or average, we actually tell QlikView, do not do this. Instead, take the numbers that you calculated for each row, sum them up, and then do the calculation only on this value. In this case, bring the average. In pivot table, as we discussed, there is no such option when we are dealing with expression. There is no total expression, total function. So we have to use aggregate if we want to achieve the same result. By default, the pivot table calculates sum of expression. If we want to force it to calculate sum of rows or max of rows or average of rows or any other aggregation, we have to use the AGGR function, just like we did here. We take the expression sales minus cost of goods and run it by the customer dimension. We get a list of values, and which is the same list of values that is written in each cell in a regular table. And from these values, we take the average. We also talked that the use of AGGR allows us to use other functions as the wrapping functions and not only those functions that are available to us in the totals function, which are the five most common one. But sometimes we might want something else, so this is the way to do it. We also talked about how we can use sorry, AGGR to calculate calculated dimensions. We said we have a table of customers, number of products per customers, which is a regular table, customer, and we calculate sum of sales. It actually is sum of sales and number of products. Let's just fix it. It's not number of products. And we've seen how we can take the inner aggregation of count distinct customer, and in this case, we have the calculated dimension, which is the AGGR function by customer, which, as we said before, will give us the list of values, which is the representation of the sum of sales per customer. So this list of values, 1 million, 1 million, to 900,000, 600, etc., etc. And we want to use it as a dimension. Let's just do a quick reminder. And we have here the list of values that was calculated. And for each one, we can count the number of customers that bought with this amount. And we also seen how we can use the class function. Since here every value is 1, you see how we can use the class function to group those values into into smaller ranges, and so we will get more customers in each of the range. And this is the formatted text. We've seen how we can use it also in a chart. And one last thing, when I select one of the calculated dimensions, this is I didn't talk about this last week, but one of the side effects is when I select, since the AGGR function does create a temporary table in memory, but it retains the links between the results of each value in the temporary table and the original dimensions. So when the value returns the list of these 3 values, it doesn't just return the values. It brings with it the knowledge to which customers these values was connected. So we can, when we select the calculated dimension, which is actually the representation of this list of numbers. Remember, this calculated dimension inside the class is just a representation of these values. So when I select it, it selects actually selects the 3 customers that are connected with it. Okay, you see when I selected this one, it didn't select any number, but it selected those 3 customers that are connected with the values between 450,000 and 600,000. Okay, so this was last week, and we're going to continue and see today a few more uses. There are a lot of uses for the AGGR function, and we will try to cover most of them, all of them, I hope. It might take more than one more episode, maybe 2. Okay, so another case where we can use the AGGR function is usually when we want to calculate what is known as the top 3 or top 5 or bottom 4 or bottom 5. When we want to take some of the top values for each measure and return the dimensions that are connected with it. So let's just take, for example, we have this chart here, and we have and we have customer and country and the sum of sales, and I want to know for each country which are the most valuable customers. I want to know how much I sell to those 3 customers. I want to know which they are, who they are, etc., etc. So there are a number of things I can do with this requirement. First of all, I must determine a way to know for each dimension which are the values that I need. Okay, which are the 3 most biggest values in the list of values of customers, sales per customer for each of this country. And for this, I'm going to use a function that is called rank. Rank is not an aggregated function. It's a function that takes the results of an aggregation and ranks it according to size. And let's see what I mean. I have here a table of sum of sales per country. I listed it, sorted it in the descending order by sum sales. So I can see that Germany is the country that I sold most of the sales to. And I take the same expression, sum of sales, and I wrap it inside a rank function. We'll ignore for the moment the other parameters and options of the rank functions. But what does this function actually does? It takes the list of values that was produced from the sum of sales per the dimension in the chart, and it ranks it. So the biggest one gets the rank of 1, the second biggest gets the rank of 2, the third gets the rank of 3, etc., etc. So here we can see that Germany is indeed the first one, and USA is the second, and France is the third, all the way up to 5. So actually, what I can actually do now is, okay, I just want for each, and we can do the same for customers, and we can do the same for customers and countries. Okay, let's add the rank function here too. Now I'll delete those 2. They just take some space. And here. Wait a minute. Let's add the function rank to this chart, and let's enlarge it a little bit. And what we get here is the rank for each customer inside each country. Since we have 2 dimensions here, you can see that the aggregate function, the rank function, knows to restart itself. Okay? It knows how to restart itself. Okay? So now I can just take this function, and I can tell it if rank times 3, and now I have only the two customer, and I can tell it. Okay, now I get only those 2 customers. We can eliminate the nulls if we wish, but I just wanted to leave them so we can see that it only selected the first two values. Okay, but what if I want to return the names of those countries? Okay, I want to of those customers. Okay, or in the case of let's undo our deletes. 1 second. Let's return with these 2 customers. I'm doing it just to keep it simple. Maybe I did it more complicated, but I just want to make it simple. Let's say I want to take these numbers here, and I want to give a list box or a text box to the customer, showing him only the top customers. Okay, only the top countries. So I can either make a table like this and sort it by the sum sales and just let him see that those are the 3 values. But I can also do it like this. Okay, I want to have a list box that lists all the table text object that lists all the countries that have that are the top countries in the sales measure. So let's see how we do it. I go here, and this is the expression that we are using, and it's a combination of a few functions. So let's relax first of all, and let's analyze what we have here. So first of all, we have here the same formula, if you remember, that I used before. Okay, to isolate the number that I want. I think I made an variable here. Okay, so I'm telling it if the rank of sum of sales is less than the number that is represented by the variable top customers, I do it via a variable, so I can give the user a chance to change this number. Tomorrow he wants 6 top customers, today he wants 2 top customers, etc., etc. So we just take this function and we check if the rank is bigger or smaller than what we need. But since we don't have dimensions, we have to generate the list of values by dimension, and the way to do it will be to use the AGGR function. Okay, so actually what we are doing here, we are using the AGGR, the function that we talked about earlier, and we use it inside an aggregate function by country. So this thing gives us the list of the top X customers by country. The top sales, we take the top sales for each the sales for each country, we order them from biggest to smallest, we give rank to each one, and we take only those ranks that are up to 5, up to 6, up to 7. And we, since this returns a list of values, like we said, a list of elements, this is the result of the AGGR function, we can pass it on to another aggregation function, in this case the concat function. The concat functions takes all the values that it calculates from the values of the records that it runs upon, and actually makes a string that is a concatenation join of all the values inside this list. So let's say we have a table sales by customer, we have 10 customers, so we have 10 values, so we will have a list of 10 values in one string. We can tell it, we are telling it what is the this one belongs here. Okay, we return the field country to count if we to concatenate if it is the rank. So this is the first parameter. Actually, this whole thing is the first parameter of the concat function. This is the source for the list of values that the concat function will concatenate. Usually it consists of one field, so usually I would put here just country, okay, and not this entire thing. I will just put here country. So I'm telling concat country, take all the values of country by the dimension that we are which is in the table or in the group by, and concatenate them with this delimiter. In this case, chart 13 is the new line, so it goes down one line. I could use another delimiter like this one, and this will be the delimiter between the values in the concat in the string, but I chose to do this here. And another parameter of the concat is, okay, you got a list of values and you are going to concatenate them, but I want to be able to influence the sort order of this.
Here's a result from the web.
I want to be able to sort the result. So the last parameter of the concat function is a sort weight expression. Remember, this sorts the outcome. So in this case, we have a list of countries which represents all the countries that are less than the list of countries, and in this case the countries only will get only 5 or 4 or 3 countries, but I want them to be sorted by the descending values of the sales. So I want the country that sold the most products to be the first, and the second will be the one after it, etc., etc. Okay, so again, let's go inside and see what we've done here. We used some kind of an aggregation function. We enclosed it inside an AGGR with a dimension. So we got a list of values corresponding to each of the values of this dimension, and we took those list of values and we passed it into the concat function, which made a string of all these values. And since I used chart 13 as delimiter, chart 13 is what orders a text file to go to a new line. It's a new line. So this is what we get. We get a text object which has, in this case, only 3, because the variable in the top cast is 3. If I change it to 5, we will now get 5 of those. So we can use the same function not only as a text box, but inside a table box, a list. Okay, it's exactly the same function. It's exactly the same function, just written here in one line, sorry. But since it is operating inside a table with a dimension, it will list for each cells only those 2 countries for each country. This text box has no dimension, so it actually represents the biggest country that I sold to in all the data. Here I'm taking the biggest customers for each country, and if I allow to show this expression, let's enlarge it. For some reason it doesn't work always inside the... Actually, those 2 characters, ASCII code 10 and ASCII code 13, just nostalgia. We used to have typing machines. We didn't have computers when I was very young. And when you were typing in a typing machine, you reached the end of the line, you had to do 2 things. You have to return the carriage, the typing carriage, to the start, and you have to rotate it so it will begin to type on a new line. So these 2 actions is called carriage return and line feed. And today they are represented by the ASCII code 10 and 13. Usually, sometimes you can go and just use one of them. Sometimes you have to use the other. I still don't know exactly why. And sometimes you have to use both of them. But anyway, what I got here, I got the list of countries. I got the total sales for each country, and I've got the list of customers in each country that are the top 5. Let's make it 3. That are the top 3 customer to which I sold in each country. Okay. Now there is another way to bring the value of the first or the second or the third value from the results of the AGGR function, and this is using another function altogether, which is called first sorted value. It looks simpler, but it has its limitation. I will talk about it in a second. Let's first explain what this function is actually doing. Okay. The first sorted value, from its name, gives us a way to take a dimension, in this case it is customer, to attach to it some kind of sort order, and by definition the first sorted value returns the first value in this list. Okay. The reasoning behind the use of the first sorted value is that I can use a numeric scale, in this example the sum of total sales, okay, as a way to select in another field. When I dealing with the total sales, the results I get from the AGGR function is the list of numbers. But I don't want the list of numbers. I want the list, the country or the name that is connected with this number. I think I did it also here, yeah, in this function. Okay, I wanted to know never mind. It's better here, this one. Okay, so let's highlight this one also and make it also here. And now I can see for each country I get the value of the customer that bought the most sales for each country. Okay, and let's go inside again and see what we have here. So the first sorted value takes the values of the customer, and here is where we use the AGGR function. We don't have a list of values to go with the customer. What I mean by that is, let's say we had in the script, in the load editor, pre-calculated the values of sales for each customer. Let's say it's called cost sales. Let's say we have a field like that. So if we had a field like that, we could use it as the second parameter of this first sorted value. We can tell qlik we are going to sort the field customer by the field customer sales. But since we don't have a field in the, usually we can do it with dates. Okay, let's say because in the calendar we take the dates, which can be sometimes a string expression like name of the month and the year, and we want to sort it. Usually the sort will be the value of the numeric year month of the field. So in this case we have the same, the two fields are in the same table, the calendar table. So we can take the field year name, year month, sorry. These are all made up fields, they don't exist, that's why year name field, and sorted by date sort, if we have this kind of field. So what will happen is it will take the list of values represented by the year num field and sort it by the data sort and give me the first sorted value. Okay, and if I do minus, it reverses the sort order, so I get actually the last one become the first and I get it as the first. So this is why we're using minus. So let's return to the original calculation. We took the customer field and we told qlik, okay, we are going to calculate a temp table with the customer as dimension. So we're going to get a list of values which corresponds to each customer. Now, it's usually very important that when we sort a certain field by a certain value, we will have a match. For each value in the field customer, we want some number to represent its location inside the list. So we have to, if we have 10 customers, we have to have a list of sort weight which has 10 values. And since we are in this case aggregating the sum of sales per customers, that guarantees that we will have the same values. The list that is returned by the AGGR function will have a number of values which is the same as the number of values in the dimension or dimension combination that we used inside the aggregate. So from this list, each value has a correspondent customer. And since we are using this with the reverse, it will give us the customer which has the highest sales first. And the first sorted value will bring this to the surface. Now, let's say one of the problems, I'm sure there are more, I can't think of any now, but I'm sure there are more. One of the problems with the first sorted value is what happens if we have two values in the dimension which have the same sort value. I don't think it can happen in dates, but let's say that when we are using the customer, we have two customers which the sales to those customers is $1,000. So in this case, what qlik does, he doesn't know what to do, so he says, I don't know what to do, and it just returns null. So if we have values that we know for sure that won't be non-distinct, then we can use the first sorted value. Otherwise, we must use a another function or something like that, or in some way eliminate the situation where we have the same value, the same top value for the two customers. Okay, I hope this was clear. As usual, if you have any questions, you are always invited to write this down in the comments, or send me an email, or contact me in any way you see fit. We didn't finish yet, don't worry. We're going to do one more thing with the AGGR, and we're going to see how we can use this, for example, inside a chart. Okay? If you see here, we have a chart, a bar chart, and I colored one of the values, which is if you can see, is the max value. So what I can do is I can do this actually. What I did here, I took the graph, and it's a regular graph by year month, and the expression is very simple. It's just the total sales. Okay, the secret lies here inside the color. If I go to color and legend, I see that the custom color is color by expression. And let's see what is the expression that I'm using here. Okay, so actually what I did here was something like that. These are the same, just return a bit of a different values. What I'm doing here, as you know it, I like to start from the inside in many cases. So we have here the sum total sales. This is the same expression that we used in the chart. Okay, and our chart has only one dimension, which is year month. Okay, so what I did here, I took the AGGR function and I used it to create a temp table, which is the same as a temp table of sum of sales by year month. So what I got is a list of numbers, a list of elements, okay, that represent the sales for each year month. And from this list of value, I took the max value. And now I'm comparing for each row of the calculation of the chart. I'm checking if the sum of total sales, and since it's a specific row, it will be the sum of total sales per a certain year month. Remember, a chart is just the same as a table. It has a dimension and it loops over the dimension values and calculates the cells and the expressions and the measures that are referenced and connected only to this value of the main dimension. So if we are in January 2015, we will take the sum of total sales for January and 15, and we will see if it's equivalent to the max sale of all the sales. And this is where I use the word total, because in this case, inside the max function, I wanted to consider all the values. Pay attention, since we are inside a loop, which is, let's say the first month is year month num January 2015. If I didn't use the total, then the list of values returned by this would be consisted of only one value, the sales for January 15. When I use the word total, and look, I'm using it only on the max. I'm not using it on the sum. Okay? This is the outer aggregation. So after I got the list of values from the aggregation function, I tell it, okay, now I want you to compare it to the same max. By using the total, I actually use the same max for each row. So the max of all the rows stays the same, and I'm comparing it with the max for this specific row, for January 15. If they are the same, I light it in green. If it's the minimum one, okay, I'm doing the same to the minimum. Okay, if the sum of tail equals the minimum of all the sales values per all the months, per all the total sales, then color it red, else color it light blue. Okay, and you can see that I have here, oops, sorry, I'm in this mode. I have here one of the values is colored with green, and if we see here, it's the same value as the max value. But what happened to the red one? I don't see the red one. You see the red one, guys and girls? You don't see the red one because nothing here was painted in red. And the reason is, ladies and gentlemen, because here we have some sales that are not connected to any month. I don't know why, I don't know how. Probably it should be fixed, but let's say in some cases, maybe not with this context of months and sales, but in other contexts, how you say context in plural? Can you say it in plural, or it's context all the time? Never mind. In this context, it's not correct, but for the purpose of this demonstration, it will suffice. So actually, we can see that the value of 49,071, which is actually the minimum value, since it is null. Actually, the color expression returns null because it doesn't know how to deal with nulls, so it returns null, so it doesn't know in which color to color it, so it leaves it in the gray color, which is probably some kind of default. So I could add a check for the null, okay, in the color expression of the chart. So this will be also colored in there. But when I'm using a chart, I can do something else. Since I know that this is wrong and there are no sales, or there's supposed to be no sales for a month, for no months at all, what I can do inside the chart, I can come to the dimension. Since it's a dimension, the null is in the dimension. I can come to the dimension and I tell it, don't include nulls. And now you can see we don't have the null anymore. But we still don't have the red one because the color expression that we are using is using aggregate, and the aggregate function does have does consider the null, so it doesn't know which color. And since this value is no longer the values of 49,000, doesn't have any months, it doesn't know how to color it. So now we have the correct values, but how we can correct this both here and both here? So here we will have also the same thing. We want the new minimum value to be the minimum value without the null year month. So it will probably be something else. Okay, and we also want to color this here with the red. So let's start here with the first thing. What we can do to fix it is inside the AGGR function. Sorry, I was in the wrong place. Okay, now we can see how we calculated this number. We took the aggregate function of the total sales per year month, and we took the lowest number. Okay, so what we want to do, and this is a little bit returning us to the first two episodes of set analysis, what we want to do is somehow force QlikSense to not consider and not take into account the sales that are connected to null year month num values. Okay, the simple and most elegant solution is to add set analysis. And we add the set analysis like this. And we tell it equal search string. Remember, set analysis, we have here identifier, which is $, which I don't need to write because it's the default. We have a modifier, which is represented by those two chevrons. smaller and larger, and inside we have a pair of field name and element list that we want to select. And here we are using the double quotes. Remember, if I'm using the double quotes, that means I'm going to put inside some kind of a search string. And the search string is star. The star character in most of the languages, in most of the computer-related languages, star means all, represents all the characters and all the words and all the values. Okay? So what I'm telling it here, I'm telling it do the aggregation, but when you come to calculate the minimum value of the result set that is returned by the aggregate function, I want you to consider all values in the year, month, num field. Now, remember, when we use a modifier, it's like telling qlik, you're actually making a selection in this field according to what is written in this field. Okay? If I have written here 2015, the calculation was going to be made as if I have selected 2015 in this field. So when I use the star search, I actually tell it select all values. It's the same as right-clicking or going to the properties of the search in the field properties and press select all. Now, if you remember, when I press select all, what is excluded by default are all the null values. So if in the field year num I have some lines in the table which don't have any values in the field year, month, num, then when I select all the values in the field month, num, the line which consists of the null value is not included, and hence I get the value of 1,298,383. Yeah, 1,200,098 and 383. Okay, and we can do the same here. I think this will work also in the you see, when I type set analysis expression, I like to complete all the surrounding parentheses and only then go inside and do my job. This way I'm making sure I will never this. Now I can take this thing and do it also here. I think this will work now, exactly. And now we can see that it indeed colored the minimum value in red and the maximum value in green. We can use, instead of equal max, we can use larger or smaller and color all the values up to the max in a certain values and all the values from the max in another color. We can do many things with this. This is exactly how I colored this here, and this always tells the always make sure you have some way of informing the user what are the colors that he sees. Maybe I wouldn't choose green and red, I would choose some other colors, or the blue, it's a shocking blue, but you understand what we can do with it and how we can use it. Okay, I think for now we will settle with this, because the next thing that we're going to talk about regarding the AGGR function, I think by itself might consist of 2 hours, of 2 episodes. I'm not sure if I can cover it all in one episode. It's all connected to the AGGR function, and but it's a topic by itself, and I'm referring to what is known as accumulation. To accumulate values, there are many uses for it. One of the uses is what we call a Pareto chart or an ABC chart. Another use for it is what we call rolling average or rolling sum or rolling calculations usually on the time series, and they are all involved in one way or the other the AGGR function. But from there we will diverse into other topics. I hope to enlighten you all. And here we will end our meeting for today. Hope you enjoyed it. Please subscribe. Please follow me on Twitch. I've posted all the videos on YouTube. I sent the link to everybody. I'll put the link here on the site as well, the Twitch site as well. Follow, please subscribe. It gives me power and will to continue. And please feel free, if you have any questions, to send them to me. And I urge you again, I heard from some people that the hour of 8 o'clock Tuesday evening is not the best ideal choice. So please send me requests of other times, and I will see what is the popular demand and I will go by it. Drive safe. Have a nice day.